Hi, and welcome to Section 2, Collecting Books. During Section 1, we built a bare-bones web server in Go, complete with template rendering and a database connection. In Section 2, we'll build on those concepts and start focusing on building features to manage personal book collections. We'll start this section by sending asynchronous communications from the web client to our server. Next, we'll fetch real library data from an external web service. Then, we'll start creating personal libraries and storing them in the database. Finally, we'll end this section with an introduction to Web Middleware to refactor some of our common code. In this video, we'll start building a simple search UI using JavaScript to send requests to our web server. In the new world of the web, it's common practice to load a website and then use JavaScript to perform more actions based on user input. Our library application will be no different. To start, we're going to need to create a simple search UI in HTML. Then we'll use JavaScript to fetch data from our web server. Finally, we'll use the data from the server to update the page on the fly. Let's remember what we've already accomplished. We built a simple web server with a single route, which renders a template showing two strings, the status of the database connection and a greeting based on the name query parameter. By the end of this section, we'll have completely changed our UI to show search results and add new books to the library. Let's get started. We want to build a simple search UI to find books, and we need to display the results in a reasonable manner. In index.html, let's remove the contents of our old body. Since we want a search bar, let's create a form called search form with an input tag called search. Next to the input tag, we'll include a submit button with the text search. Next, we'll need to define a location for our search results. Let's build a table. Our table will have a width of 100% to take up the entire screen. A table in HTML consists of a t-head tag and a t-body tag. The head tag is a list of headers for the table, and the body is a list of rows. For the time being, our body will be empty, but we'll give it an ID of search results so we can easily find it in the JavaScript later. In the head tag, columns are defined by th tags nested within a tr tag. Let's create headers for title, author, year, and ID, and give them some reasonable widths. Since we want to start quickly working with asynchronous requests and HTML manipulation, we use Jquery in our project. Jquery is a fast, small, feature-rich JavaScript library which will give us a simpler API to access browser functionality. In our template file, index.html will add a script tag for Jquery. We'll use a known content delivery network or CDN to include Jquery so we don't have to keep a copy locally. This link references version 2.1.4. Add another script tag of type JavaScript below the Jquery script tag we just added. We're going to add a few lines of JavaScript to make a callback to our web server whenever the user clicks the search button. We'll create a new function called submit search. We'll use Jquery's AJAX to send a request back to our server. We'll make this a post request with the URL /search. To submit our search query data, we'll serialize the search form. At the end of this function, we need to call return false to prevent the default button action from being taken. Back on the search form, we'll set the onSubmit attribute to return false so the browser does not submit the form. On the button, we'll set the onClick attribute to call our submit search function. Okay, let's make our way back to our main.go file. We'll use handlefunc on our default router to manage incoming requests to the /search endpoint we're calling from the JavaScript. Just like with the root route, our handler will take a response writer and a request as input parameters. We should create a struct to represent outgoing results, so let's create one called searchResult with title, author, year, and ID string fields. For now, we'll ignore the search string and just return some dummy data. We can use the square brackets to denote a slice of search results. These are a few examples I've created. Now that we have data, we'll need to encode it to JSON to return to the request. Let's add encoding /JSON to the import list at the top of the file. Now we'll use JSON.newEncoder to create an encoder object using the response object as an output stream. The output stream is what will be written to. We'll use encoder's encode method with our results array, which will immediately write the output to the response. If encode returns an error, we'll use the http.error method to let the client know. Finally, let's create rows in the table representing the data our server is returning to us. In the AJAX call, we'll add a success callback. When the call is successful, we'll parse the JSON data with the JSON.parse function. If the result is falsy, we'll return immediately as we know we were given invalid data. Next, we'll create an object to reference the search results table body using jQuery's $syntax with a hash symbol and the table body's ID. If we call empty on this object, any past results will be removed from the table. Now we can iterate over the results we've parsed and create a new row in our table. We can create the new row object using jQuery's $syntax and inputting a new string of markup. We'll create TD objects for each column nested inside a parent TR node. We can then use string concatenation with the properties of the JSON object parsed earlier to build our rows. We'll need columns or TD tags for each of title, author, year, and ID for every book. To add this object to the table, use the append function. And that's it. We can now restart the web server using go run main.go to see the results for ourselves. Whenever we hit the search button with text in the text box, we can see that the table will be populated with the results. We covered a lot of ground today, but it is well worth it. In this video, we started putting interactive elements in our UI, and we sent and received data from the server to update our web content.